Hello, everyone. Welcome to our second Tech in the City webinar. This series will focus on how people plan, move, and engage in a new urban and technology age. Today's guest will be Kristina Wolf, and she will provide an insight on providing real-time data to improve support and emergency services. My name is Jerica Logan, and I am the Outreach Coordinator at the Center for Urban and Regional Analysis, otherwise known as CURA. I will be your host for this event. If you require closed captioning, you will find a box at the bottom of the screen called CC. Click the box and select Show Subtitles. This will allow you to see subtitles during the presentation. Please feel free to submit questions at any time during the webinar in the Q&A box. We will ask as many questions as we can in the last portion of the presentation, and if we do not get to your question, we do apologize. If you have any additional questions following the event, please feel free to email me at logan.433@osu.edu. There will also be a brief survey at the end of the webinar. If you have time, please provide your feedback. I am now going to pass it over to our director, Harvey Miller.
Okay, thank you very much, Jerica, and welcome everyone to today's special seminar. This is part of CURA's regular series on issues and challenges facing the cities and regions in Ohio and beyond. Our next webinar in this Tech in the City series will be on November 18th, and that will be Dr. Elizabeth Delmel from University of Pennsylvania, who will speak on text as urban data. So that'll be on November 18th at noon again. Just visit us at cura.osu.edu/events to register for this event and learn about this and other future events. Sign up for our monthly newsletter at cura.osu.edu, and you can also like us on Facebook and follow us on Twitter and Instagram, and that way you'll never miss any of the exciting events that we have here at the Center for Urban and Regional Analysis at The Ohio State University. So today I have the pleasure of introducing Kristina Wolf. She is a visiting PhD student from Newcastle University. We're very lucky to have her this semester in CURA. And she'll be talking about, as indicated on the screen, something that's near and dear to our heart, which is how to use data to improve responsiveness within urban systems. So Kristina graduated with a Bachelor of Science degree in International Management for Business and Information Technology, and she has a Master's of Science in Management Information Systems. The focus of the latter degree was Geographic Information Systems. During a research seminar at the Transportation and GIS Laboratory at Tohoku University in Japan, she worked with static and dynamic data from probe vehicles and analyzed the effect of natural hazards on transportation networks, something that's very important here in our future in Central Ohio. For her master's thesis, which involved identification of pilot areas for broadband expansion using GIS-based models, Kristina was awarded with the Esri Young Scholar Award in Germany. Congratulations on that. And she also did an integrated Master's of Research in Geospatial Data Science. And in this project, she developed a geodatabase model to estimate flood impacts on the environment, society, and infrastructure for Newcastle upon Tyne, and had the opportunity to present her work at the Esri Resilient by Geodesign Summit. So she's very well qualified, as you can tell, to talk about the role of geospatial data and how to respond to hazards and risks in cities. So now I'll turn it over to Kristina, please.
Well, thank you very much, Harvey. Thank you a lot, Jerica, for this introduction. And I would like to welcome you, everyone. Thank you for your time. Thank you for joining this presentation. I really appreciate it. So I am Kristina Wolf, and I am a third-year PhD student with the Center for Doctoral Training based at Newcastle University. Our CDT is a joint collaboration between the University of Nottingham and Newcastle University. And I'm currently visiting CURA here at the Ohio State University. And I am very excited about this opportunity to be talking about integrating multi-scale real-time data for supporting safe and resilient cities. I hope that this talk will be interesting for you, and I'm very much looking forward to our discussion later on. I have a brief overview prepared for today of the points that I would like to cover. So first, I'm going to start off with an introduction about my background and my current research. We are then going to look at natural hazard impacts on the cities and the environments. And by that, we will also cover the need for a geospatial framework that actually enables multi-scale real-time data integration. And to make this more specific, we are going to have a look at a case study to demonstrate how we can integrate multi-scale real-time data for Newcastle. And I would like to conclude the talk with a reflection on my work and also with our discussion. In 2019, I joined the Center for Doctoral Training in Geospatial Systems as part of the first Cohort 1 intake at Newcastle. And our first year included an integrated Master of Research in Geospatial Data Science before we moved on to a 3-year PhD. As part of my research, I now have the great opportunity to be doing a research visit at the Center for Urban and Regional Analysis. And I'm very much looking forward to learn about the geospatial data infrastructure at place. And I'm very happy about this opportunity and our future collaboration. As Harvey has already mentioned, I hold a Bachelor of Science degree and a Master of Science. And within my 2-year Master in Management Information System, I did have the great privilege and opportunity to be spending a research abroad at the GIS and Transport Lab at Tohoku University, where I had the opportunity to learn a lot about natural hazards and how GIS technology can assist in disaster risk management. Here are some ways of how you can get in touch with me afterwards. So one is LinkedIn. The next one is a link to our paper, which we have recently published. And this link will take you to my profile as part of the CDT. And I believe that we're going to share the actual links later on as part of the video descriptions with you. My PhD is funded by Ordnance Survey, the National Mapping Agency for Great Britain, under the very broad topic, multi-scale, multi-domain geospatial data modeling. And the overall aim is to link different spatial domains, such as water, transport, society, and the environment, and thereby enable data integration, modeling, and analytics at different scales. As this is a very broad topic, we are focusing here on real-time multi-agency incident response. And the aim of this research is to develop a geospatial data infrastructure and also design a data model that will then enable data connectivity and exchange across different stakeholder groups that are involved in incident response, as well as their independent systems. Now, a major area within my research are real-time or near real-time data. And therefore, my research aims to explore how we can use the raw data captured from internet-enabled devices, IoT devices, and then transform this data into intelligence, thereby support multi-agencies in incident response, and also improve the overall resilience as such. Well, in recent years, we've actually seen a series of different natural hazards all around the world, which have led to fatalities, caused a lot of damage to the human environment, and also economic losses. Research shows that those kind of extreme weather events are likely to become more frequent and also more intense in the future with climate change. And the future rainfall could actually be more extreme than originally anticipated. And this is the reason why preparedness, rapid response, resilience to these sort of events is now more important than ever. And luckily, we do have certain geospatial platforms as well as different geospatial data available, such as the Copernicus Emergency Management Service, for instance. And this one provides emergency services with different geospatial information that they can use in their disaster risk management. We can see here a screenshot of the European Flood Awareness System that will provide stakeholders with on-demand detailed information for different emergency situations, such as a rapid impact assessment on the population, on the land and infrastructure at risk, as well as with different flood probabilities. for instance, within the next 48 hours, also beyond that. We also have different data sources, such as flood hazard maps, which then help us to answer different questions, such as, is my house within the flood zone? So one example of such flood hazard maps is available here, which is published by the Environment Agency. So these sort of hazard maps give us different indicators, such as the flood extent, the flood velocity, and also the flood depth. So the wider the flood extent, the more residential buildings might get damaged. Flood velocity is quite important because the running water can actually move more debris and therefore also lead to more destruction. And flood depth is something which we have used in our analysis. Is directly related to any potential damage. So by using the postcode, we can see here, for instance, that one of those critical infrastructures is at high risk of flooding. And these sort of information would be available for different probabilities. Another source that would give us more information are so-called flood warnings. And here, the flood warnings would give us answers to questions such as, are any flood alerts issued for my particular area? Here we can see a screenshot from a storm event from 2 years ago, where the UK was hit by a severe storm, which caused a lot of damage and also loss of life. And we can see here that over 251 flood warnings were issued. Flood impact assessment is particularly complex in cities. And one of those reasons is the complexity of those urban environment that presents different challenges for response due to their different layers, such as we have roads, buildings, different kind of infrastructure, and as an incident such as flooding can occur within such a short period of time, we would really need high resolution urban data and also real-time information to understand how flooding might affect the road network, can damage residential buildings, shops, and also disrupt the other infrastructure. And how this can look in reality, we do have a video here that will show you the impact of a storm that occurred last year in October in Newcastle. So in this video, we can see a major road in Newcastle where several incidents have occurred in a short period of time, such as congestion, road closure, also flooding. And if you have a look at the timestamp, we see that was still early in the morning. And later in our analysis, it was actually visible that those sort of incidents led to all other cascading impacts and also further delays in the wider city area. Now, at the same time, we do have different Internet of Things technology, IoT devices within cities nowadays that connect different elements and also help us to gather high temporal and spatial resolution data. And we can use this data to then conduct some impact assessment as well as support better response. And examples of such IoT devices might be sensors, traffic detectors, cameras, or mobile devices. So this really brings us to the need for the multi-scale real-time data integration. Because in order to really make use of this raw data that we just captured from those smart internet-enabled devices, we would really need this geospatial framework to be able to transform the data in a way that we can later use for analysis and also visualization. In my research, I have adapted the systems engineering design, which helps to develop the incident response system in an iterative manner. So I'm going to show you briefly some of the steps that I followed. The first one was to define the research problem and the current incident response. The next step was to identify stakeholder needs. Based on those stakeholder needs, we could then analyze functional requirements for an improved incident response system. We'd then be able to design the incident response system with all the different components included. we could then gather feedback, and this is very crucial throughout the entire project, as this actually enables us to continuously integrate feedback into the prototype development. And finally, we would have the prototype development. So I'm going to jump into the individual steps and give you a quick overview of the contents involved. So although there have been many great advances recently in multi-agency response, such as the integration of common standards, both literature review and also the discussions with stakeholders, they highlighted different areas for improvement. So for instance, emergency services, they tend to not utilize the smart data collected from those internet-enabled devices, such as sensors, cameras, or social media. However, it is this real-time data that can be really useful to coordinate multiple services and actually assist the operation response. For example, when we refer to the previously seen video, we could actually use more data to help navigate an emergency vehicle to an incident site where there have been some other incidents occurring at the same time. For instance, if a certain road has just been closed. To be able to really identify the stakeholder needs, we have split this task in half in two different components. So the first step was to really identify the relevant stakeholders. There are different stakeholders involved in the operational incident response, those who deal with the incident management in different stages. Other stakeholders, they help to generate data. And in other groups, they are there to really use that data to make decisions based on it. So I did have the privilege of talking to many of those stakeholders. I used semi-structured interviews to cover main areas, such as the current process in place, the people they collaborate with, the data used, and future data for any other potential analyses, current technology in place, as well as any analytics that is currently performed or that might currently be lacking. So the main goal here was really for me to understand the flow of data as well as information between the different stakeholder groups as well as the systems. And although each of those discussions were quite unique, there were some common challenges that were identified throughout. And some of them included the current heterogeneous data landscape, so different systems within organizations, also from different vendors and suppliers. A current missing joint overview of any data that is currently available. And really the integration of real-time hazard, weather, and traffic data. And these are just to mention a few. So based on these findings derived from discussions, we would then be able to identify functional requirements that would support stakeholders to respond to incidents more efficiently. For instance, certain capabilities would include that the stakeholders could indicate how many people, buildings, roads, critical infrastructure in general might be impacted by flooding in real time or near real time. Stakeholders would also need to be able to view available, but also the allocated resources to an incident for a better cooperation. They would need to be able to integrate real-time traffic, weather, and also social media data. And then to be able to really send and receive automatic updates through one common system. And this led us to the design of the incident response system. So there are certain elements that would need to be fulfilled and requirements to be met. One of them was the actual incident handling. So the system would need to be able to capture the incident and be able to capture the surroundings and visualize it on a map. Therefore, the system would need to first be able to connect to those sensors to extract different data to be really able to enable stakeholders to perform different analyses, different simulations, as well as the visualizations on a map. And this data should really be the basis for deriving decisions, which really means turning this raw information into intelligence. Because based on those insights, stakeholders could then trigger different actions such as notifying other stakeholders, also deploying resources, which would then be responsible for performing certain incident response until the condition of the incident has changed. And what you see down there is a certain feedback loop, which would always provide us with continuous real-time updates. Now, as incident management is such a collaborative approach, there are all kinds of different data available from different sources. So we can start with a very broad view at the global scale. So we can include all satellite images. We can further have a look at information of land use, land cover, some critical infrastructure such as roads and buildings, further information on the population, the society, vulnerable population groups. And then we'd be able to include some dynamic information to really enhance any static data, such as current river and sea level measurements, the current weather, traffic information, and also real-time tweets. And obviously, if we have a look at all those kinds of different data from different sources, we'd soon realize that data is available at all kinds of different scales. So the data might be available for a country, for a particular region. We can have a look at one particular city. And even then, depending on different available geographical areas, we can further drill it down for census reporting levels, for instance, in England, where we have middle super output areas, lower super output areas, or output areas, which really help on the reporting on the different geographical areas and those small area statistics. Well, there are different steps required to be able to obtain those data insights and to really inform later decision making. So based on the different understanding from the literature as well as the stakeholder discussions, we then know what kind of data is needed. We'd be able to extract those different data and really transform it for the basis of later analysis. And as you can see here, there's quite a list of different elements included. And I'm not going into too much detail here, but I would really like to highlight some of the tools that have been very useful throughout the research, such as an integrated development environment that was compatible with different platforms, different programming languages. And what's also quite important that these tools were used with regards to the different research questions. So in case there are some other research questions, then there are different elements that would need to be deployed in order to address those needs. And regarding the analysis and visualization, we have used here mainly the Esri and Microsoft stack, as they offer software development kits that allowed for quite customizable solutions, which proved to be very useful. And then again, the actual aim was here to really provide those data insights for stakeholders and then support their informed decisions for future natural hazard impact assessment. So following the various steps you've seen on the previous slide, and including the static and dynamic near real-time data, I would like to share with you some of the questions that we would be able to answer. So stakeholders were interested in knowing as of which roads might be blocked due to flooding. How many vulnerable people require special assistance? What is the estimated time of arrival of the closest responder? How many cars have passed through the incident area? Is there a potential risk of flooding? And are there any other weather hazards which have been published? Where are the most travel time delays recorded? Where have different types of incidents occurred? And are there any flood-related updates on social media? So I would now like to head over to our use cases. I have prepared 3 demos that I would like to share with you that I've been working on through the development of my PhD. And the first demo actually includes the development of a geospatial multi-scale flood database for Newcastle. which would enable us to assess the impact of surface flood water under different conditions and also different scenarios. For instance, the impact on the environment, the impact on people and society, as well as the infrastructure. Now, in the following, I would like to share with you some examples of visualizations that served as a prototype to really show how we can integrate data from different sources, how these different data sets can be combined in an accessible web application that would really enhance the integrated impact assessment for all kinds of different stakeholders. So we are going to focus here on the study area of Newcastle. We'd be able to show the current temperature as well as the river levels in terms of key performance indicators, as well as further down below, we can integrate any flood warnings, some of which we have seen previously. We can also have a graph visualizing the current river level at a certain location. And right next to it, we would see the daily accumulated rainfall. If we want to focus on the impact on infrastructure, we'd be able to explore a list of financial damage estimates. So these are estimates calculated using a variety of different sources, because we would really need to have an overview of the different building types, the age, as well as the potential flood depth. And below the list, you can see another count chart showing you the number of flooded buildings per flood depth classes. And I'm just going to click on the video where we see that we can actually further drill down the scale on another level. So we see how the map extent changes. And we can really go through the different items on the list of the estimates and see how many buildings might be flooded per particular flood depth. To the right, we also have an overview of different land that might be impacted, such as agriculture here. Further, we can perform even more detailed analysis. So if we stick to the filter here on the left, we can really use any other MSOA, LSOA, OA, and we see how the map changes. And at the same time, it'll give us further key performance indicators, further lists, further traffic information of that particular area, as well as some further information for the output area scales, such as the number of vulnerable population groups or one-person households. And then again, these individual components are highly customizable, so including various types of charts, maps, lists. It was really that this tool served as a test tool to get feedback from stakeholders on their required analytical capabilities that I would then be able to integrate into my further PhD research. Another demo is where we focus on assessing the storm impact on the transport network. Here, we looked at different types of incidents. We looked at the impact of heavy rainfall on travel time and also at sentiment. So here we can show how we can capture the current storm progress. Again, we'd be able to visualize a map extract for our study area Newcastle for a certain time between 11 a.m. and 1 p.m. on the day of the particular storm last year. And using data from sensors deployed by the Urban Traffic Management Control Center, we'd be able to display the current rainfall in form of a key performance indicator as well as a visual graph. Further, we were interested to know where did different types of incidents occur. And here you can see a list to the right side of the map, which shows you the different descriptions of any recorded flood events, such as the severity and also their impact on the transport network. And below, we also see another list of further incidents such as lane closure or congestion. To analyze how the traffic network has been impacted, we then wanted to include some further KPIs on the journey time, on the car count, any other images, and really to compare that to historical data. And for that, we had a look at different data that was captured between a set blink distance of traffic detectors using automatic number plate recognition cameras for the previous 4 minutes. And this was actually quite interesting to really see as of like what the average sort of journey time is based on a reference, and then how the journey time actually fluctuated and how it was different on this particular storm event. We'd also be interested to see what impacts have been tweeted. So what kind of information can we extract from any social media tweets? And with that, we looked at certain real-time updates, which I'm just going to go into some more detail on the next slide. So due to the continuous flow of any large amounts of data coming in, especially during natural hazards, it would be quite useful and important to automatically flag incoming tweets which are incident relevant. And it'd be also important to distinguish whether the tweet contains any positive, any negative, or any neutral comment. Therefore, we have used a Python library, the Balance Aware Dictionary and Sentiment Reasoner, which uses a sentiment lexicon that contains intensity measures for each word, and it'll then calculate a compound score based on the positive, negative, and neutral component. So it was quite interesting to see that there were certain tweets such as the flooded road has been cleared and traffic can resume, or relief following heavy rain flooding the railway, the line has now reopened, have been flagged as a positive sentiment, whereas other tweets such as road infrastructure is devastated, the flooding and traffic chaos in Newcastle are negative. So it was very important here to experiment with different data and sentence structures to be able to then support stakeholders who are interested in these sort of analyses, because I'm quite aware that in terms of social media, there's a wide range of different analyses, and it can really open up the door for another PhD. However, what has been also quite evident in the discussions with the stakeholders was that some information would be simply missing if social media was not considered at all. So therefore, we have done some approaches as of showing how it can be actually integrated. Another focus was also on the location analysis. So not only by focusing on geocoded tweets, but by really having a look whether certain street names within our study area have been mentioned in the tweets. And if so, we'd be able to extract certain street names and then geocode that in our analyses. So these are also some approaches we have done. The final demo I would like to show you today is towards a digital twin for incident management. And in this demo, we have implemented certain features, such as performing geofencing analyses around a certain incident location, based on which we would then be able to send automated alerts. We could then notify stakeholders when responders have entered a certain scene, and also provide them with the estimated time of arrival, and really integrate location-based incident data, including any weather hazards or traffic updates. So I'm going to show you a few examples of steps that can be integrated. So first of all, we're going to detect a certain incident, which we then be able to visualize on a map. We can then identify the impacted area by posting a certain buffer, which again is variable depending on the type of incident, to really assess any critical infrastructure. We can then view available responders as well as their any descriptions to them, any properties and their locations. We'd then be able to identify the suitable responder, identify the time, the distance, and the estimated time of arrival, and then calculate the route to the incident while integrating real-time weather and traffic data. And here I have a short video for you showing all the previously mentioned steps. So in the upper part, you'd see all the outputs mentioned before, starting off with the location of the incident, with the buffer, with the available resources, and then location of the closest responder. There are certainly all kinds of different REST application services available, which will help us to also simulate an incident, here the red marker, identify a certain buffer, again, variable, and then obtain location-based data, such as we can see here on the traffic and the current weather condition, as well as toggle the current traffic flow. So we are already on covering the last part of today's webinar, where I would like to mention on the reflection on the challenges as well as opportunities. So all the individual demos as such, they have really shown how we can support multi-agency cooperation and really the holistic incident management workflow, starting off with the detection, with the monitoring, and also the handling of the incident. We would also be able to provide a shared analysis and risk assessment of common data, which we have then extracted from multiple systems, really in one place, because this data has been previously in the independent data silos, and we have found a way to really integrate the data for a more holistic overview. We would also be able to improve the situation awareness by getting all this different data, by really integrating it and enhancing it with real-time information, and really provide advanced spatial analytics. Because the overall aim is here to really support the resilience of our communities through the early risk detection, mitigation, and effective response strategies based on all the lessons we have learned. And how this can feed back into my wider PhD is that all the developed use cases, they have helped me to reflect on all kinds of different challenges concerning the data availability, data integration, information exchange, while also at the same time really highlighted the role of a geospatial data infrastructure and the importance it has in a multi-agency environment, because incident management is a collaborative approach and it's really a shared responsibility. And to wrap things up, I would like to provide you with some of the lessons learned throughout my PhD journey, as well as some best practices that have really helped me along the way. So I have found that applying the systems engineering approach was certainly a very good fit in the entire research design, because it really helped me, like from the beginning, to really identify the current problems, to really identify the stakeholder groups that I would really want to talk to really understand as of what are the current challenges, what are the current data sets available, and where is the actual gap and the opportunity for my research. It was very useful to have discussions with stakeholders from different sectors, because that really provided me with a multi-perspective view, and that really made sure that we would not only focus on one particular group, but have this sort of like holistic approach at integrating different perspectives. It was also quite useful to have certain visualizations, to have certain mock-ups and analyses already developed, because that was really something which we have found quite beneficial in different discussions, to really have something to look at, to discuss, for me to get feedback and to really take that forward. Right, so this is basically, and the stakeholder discussions, they really helped me to obtain so much research feedback, and it has continuously informed my research as such in an iterative manner, to really be able to go back to certain stages to validate and verify and be able to always integrate that through the further development. And really to focus on the added value of integrating different multi-scale real-time data, because only by doing so we'll be able to actually uncover some patterns, to really do new data discoveries and have this meaningful contextual interpretation of data that would not be possible if we had just been looking at data in isolated views and different data silos. And with this, I would like to thank you for your attention. I would like to thank my supervisory team, all the stakeholders involved. And thank you very much, Jerica and Harvey, for giving me this opportunity. So I'm looking forward to our discussion. Thank you.
Okay, thank you so much, Christina. That was really fascinating. This seems like a very ambitious project, and it's something that certainly has relevance here in Central Ohio, because we're also facing flood risks, and a system like this would certainly help us to respond to these type of instances. So I'll just remind the audience that you can go ahead and put questions in the Q&A, and we'll get to know a little bit later. But I'm going to start off the discussion, and I'm impressed by the scale and comprehensiveness of this project. And you make it sound, I don't want to say easy, but you do kind of make it sound like, well, everyone kind of played well together and it was an easy process. But I know it wasn't. So can you tell us, what do you think are the biggest barriers you faced in trying to put this system together?
So I believe well, first of all, the majority of the research has been done during very difficult times, as it was right throughout the COVID pandemic. So that alone was fine to challenge to do most of the research remotely. So in the beginning, it was definitely a very big task to be able to figure out who are the people to talk to. So who are the different stakeholders in the area who might be interested in this research? What kind of data is available? And in that case, it was very useful to start as of where I was at that time, to really have a look at our research groups at the university, to really to ask him just questions as of, could you maybe put me in touch with this person? And well, I was very lucky that people were really much willing to help, and therefore, despite the difficult situation outside, I was able to do lots of the discussions online. And while doing so, it was obviously also a big challenge to really emphasize the added value of the research. And I would just like to say that it's very important to get people on the same page, to really show the sort of like added value that such web application with all kinds of different data sources really can bring. Because quite often people might not be even aware of the sort of like data sets which are available, because this is a sort of like situation where I found myself in, to really think, oh, but I think I've been in this area for some time and I might actually know all the different data sets, but there's really just so much out there, and it just takes so much time to really get this holistic overview. And you get this overview by really talking to people, because someone might give you a recommendation to look somewhere else, and all of a sudden you take like all those different turns, which then after some years will actually result in such a great data catalog that will hopefully be beneficial for all those different groups. Yeah.
I mean, I can imagine that when you can show bringing this data together, and you said you used mock-ups and things like that to show people what this would be like. I imagine people can see the value right away. The different stakeholders can see the value. But at the same time, stakeholders are busy and they have already designated missions and responsibilities. How do you get people to kind of like take on this new type of responsibility when they're already stressed for time and probably resources in their operations?
Yes, I mean, even there was no COVID, as you say, people would be busy with all of their like daily operations, with their daily work, and then especially like from March 2020, there have been like all kinds of other challenges on top of that. So it was really about like finding different ways, finding different opportunities to be speaking, well, to reach out to people via mail, to take any opportunities to have a webinar, a presentation, to really show the sort of like iterative approach, that it's not something which I kind of like set out there in the beginning to do and then sort of like disappear and see whatever I'll come out with, but really to sort of like keep engaging, because it was really the input throughout this iterative stakeholder approach that would always give me something new to think about, something new to go back, to develop something to think about, and then really come back. And by that, at least I hope that stakeholders really saw that whatever input they provided me with, or whatever they sort of like contributed to the research, would actually hopefully manifest and the sort of like other mock-up or sort of different analyses that this research could take on. Particularly this year was something with the social media, even though social media can be very difficult, as we all know. This is something which I just wanted to have a look at, because by talking to people who say that whenever they are in an incident command center, and they know that even though they have their different platforms and data available, that quite often it is really, well, these are the views of some local residents which just know the area so well. So these are all very important inputs that would otherwise be not considered if they didn't look at social media. So.
Certainly, but you're integrating not just stakeholders, but you're integrating people in organizations with different missions and outlooks. Was that particularly challenging?
Was particularly because many of the organizations, they have different strategic goals. So depending on the sort of level that they are operating on within a city, some might be more looking at strategic goals in terms of like a certain highway approach. Others are more interested in the roads in one particular study area, for instance, and therefore it was quite challenging to really integrate those different sort of like views and aims. But I think on one of the slides, I show you like some of the different questions, right? These are just some exemplary questions of a very big catalog of questions that could be asked, but this again, it depends on the data availability, on the sort of like, available information. And then obviously we could tackle those different approaches as well, hopefully covering different aims and targets.
Okay, thank you. So you're addressing a particular type of incident, which are floods, which can be very rapid onset, very sudden, and it requires real-time response. I wonder if you could speculate about more general uses of this approach. I mean, there are some challenges that cities face, which are more slow-moving, but more enduring incidences. Like I'm thinking like heat events, also like pandemics like we just went through. I would also think of other things like housing affordability, lack of access, these more enduring problems that basically involve both short-term and long-term solutions.
Mm-hmm.
And I'm wondering if you could speculate a little bit about this, how your approach might change for those type of events and incidences and problems.
So I would say that, as you have just mentioned, that there are all kinds of different incidents which might be occurring, some very short term, other which might be lasting for a couple of months or a long period of time. And therefore, it really depends on, again, like what kind of data is available, because it really boils down to the fact it's like, how can we provide any sort of like informed decision? Well, we can only do so if we have a certain like type of data to work with, right? So therefore, this approach, and like I'm talking about the systems engineering design, as well as the whole like ETL process from extracting, transforming, loading, and analyzing the data, it can be pretty much applied to other complex environments in which different agencies collaborate. Because what I've presented to you today is really like more focused on incident response. However, there are so many different examples within our community where we still have a certain type of like similar project environment, because we have different people. People are interested in all kinds of different analyses. And therefore, by what I believe, by following this sort of like a general approach, we'd also be able to tackle different questions, such as a pandemic, for instance. So it really, maybe there'd be like other, sort of like real-time data that would be useful for these sort of incidents. But I truly see the value of following a certain like generic approach, but just applied to other incidents.
Okay, thank you. I'm going to turn it over to Jerica in just a couple minutes to field a couple questions from the audience, but if other people have questions, please go ahead and put them in the Q&A or in the chat. I was interested in the third example you gave about digital twins, and I've been thinking a lot about the role of digital twins in urban science and planning and management. So it seems like you're using digital twins and you can simulate like an episode, like an incident or something like that happened, and then simulate what the best response would be. How can you use both this data you're describing and digital twins in order to get more general knowledge about and more actionable knowledge about like, for example, infrastructure. I mean, can you embed this within an experimental design to figure out where the vulnerabilities and points of failure are?
So there are certainly many different aspects you have mentioned there. So I'm going to, I'll see how to address the different ones, starting off with the digital twin. So as we all know, there are all kinds of different digital twin solutions out there, right? So basically having the digital representation of a physical object, or what we have done in our research is to have a first example, a prototype of a really operational business process digital twin, which can really support the holistic incident management approach. And in terms of data analytics, which could be all sort of like, based on top of that. And as you say, that if we had more historical data available, right? So in our digital twin or the community, then certainly there'd be different analyses that we could tackle. Also, like when I mentioned the historical travel time data. So like this is the sort of like the added value by having the historical data sets to refer to really derive any lessons learned, and then enhancing it with all this real-time information. This is how this digital twin approach can actually be very useful by having the historical data, by integrating it with real-time. And then, as you say, it can all go to predictive analytics to sort of like where are areas, what areas are prone to flooding, during what times are certain types of incidents more likely to occur, right? So these sort of questions can be answered by our historical data and by all kinds of different data coming in real time. So there's a lot of potential out there.
Okay, great. Thank you for that. Those were kind of tricky questions, but your talk just got my mind kind of going on some of these issues. So very good. Jerica, please, there's a couple questions in the audience, from the audience.
Great. So I'll first start off, somebody asked for the case study example, is that on a ARC online format?
So the two case studies, the first two demos that I referred to, those have been developed using the Esri stack, the Arc GIS online, but also the different operations dashboard and experience builder. And then again, there are some software development kits available, which allow you to really develop them in a sort of customized manner to have your different sort of like, KPIs, graphs, because all of those are developed by really addressing different questions. But yes, you can certainly do that with some of the ARC tools available, yes.
Perfect, thank you. And then our next question is asking, every incident has a distinctive characteristic. The corresponding social media, news, and real media data are different too. How does the system know which to analyze and perform for a specific incident? And how do you come up with a comprehensive list of analysis for such a system that may fit into every incident?
Right. Again, lots of many great aspects to that. So I'm just gonna go like through the question as such. So how does it know which analysis to perform? Well, the demos that I've shown, they have been developed with certain analyses to perform in mind, right? So in reality, all of those different analyses can be adapted. They can further be enhanced. Other sort of like analyses can be also added to that. So the one case, for example, was really to have the flood impact assessment on different scenarios. So again, here, this was a certain like an analysis split in 3 different components where the system knew that we are interested in this sort of information. So please get us the data, transform it in a way, and then really visualize it like that. Another one was where the system knew that we were interested in the impact on the transport network. So then again, we knew sort of like, take the historical data, show us as of how the current travel data is actually different, what kind of, like what areas, what roads, particularly some major roads in Newcastle, which are prone to flooding and what is currently going on and what are the cascading impacts. And then again, the other analysis was to really not so much of an analysis, but to have this really operational business process of like, how can such a digital twin really operate? And yes, these were the examples built throughout the research. But as you say, that if you just really have to configure the different system elements to really cover your different needs. And then you've also asked us, how did you come up with such a comprehensive list of analyses? So this was really based on lots and lots of literature review. What is currently out there? What do different cities already have? Where is the area for improvement? What is currently lacking? And then in addition to that, all the input that the stakeholders provided me with by really showing, so these are the current sets that we have, these are the platforms that we refer to. However, these are the sort of analysis which we would like to see in the future. And this is something which would always be, like iteratively come into my very comprehensive list of potential analyses as such. So yeah, I hope that I covered all the different aspects of the question.
Yes, thank you. So I have a very basic question. Is this working, this system? I mean, is it having a positive impact on incident response? And how are you measuring that? I know you talked a bit about key performance indicators, but I mean, in the ground level reality, are incident responses better because of the system? Or haven't you got to that point where you're measuring empirically whether it's working?
So now that I've spent the first 2 years of my PhD designing, developing, now I'm coming to the part of the actual evaluation. So I'm more than happy to invite all stakeholders who are interested in this research, who are performing operations in response, who are interested in different analyses that such data can bring. I'm very much looking forward to reach out and to really integrate this sort of stakeholder feedback into my evaluation part, because I have had several different discussions in terms of the different mock-ups and like really showing the individual components. But now that the final prototype is in the making, I'm really much looking forward to having the evaluation and hopefully see that actually in practice.
And do you have ideas how you'll measure success of this system once you start doing that evaluation?
So you know that for the actual analytical requirements, which we have set out in the beginning, those were also based on certain standards, which people would refer to like in the industry whenever they would develop such a software. So obviously, like when I developed these different elements, I would always look into the standard. And then now for the evaluation, I would actually do the same to see. So if this was something that was set out based on the standards and based on the discussions literature, so how does it actually, how did this manifest and how did this actually, come into development as such, to really go back, again, iterative manner to see, yes, so here we see that certainly by integrating these sort of components, stakeholders report in their evaluation, this certainly enhances them. So.
And one last question, you talk about the challenges and opportunities of bringing this system together. I'm wondering, what are the challenges of keeping it going over time? I mean, do you feel like they're different? How do you keep a system like this operational? I'm sure that that's challenging too.
Yes, I would say that we can talk about the data, we can talk about all our, luckily we do have nowadays access to so good technology and the resources available to us. But at the end of the day, it really comes down to the human aspect, because all this technology needs to be used by the humans, needs to be used by people who are working in the operation incident response, who need to use that data, and even though the system obviously helps them in all kinds of decision making by providing the analysis, it is really the human aspect that drives this added value, because even though the data is out there, even though the analysis is out there, we would need to use that. So I would say that this is how we can actually keep it going.
Okay, well, we're just about out of time. So thank you so much for sharing this work with us. This is very interesting and very relevant to some of the things we're trying to do here in Central Ohio. So Christina will be around until early December. If you want to meet with her and talk about some of her work, just contact us or contact her directly. What's your name number now at Ohio State, Christina?
My name number is Wolf.959.
Okay, there you have it. So you can contact her directly. Okay, thanks everyone. I look forward to seeing you on November 18th when we'll welcome Elizabeth Delmel from the University of Pennsylvania. Goodbye, have a good day, and as always, stay safe.
Thank you very much. Appreciate it. Thank you. Bye, everyone. Bye.